Hello, geometry students. In this lesson, we're going to start talking about cross-sections of solids. What happens if you take a solid figure and you slice through it? So, for example, if you have a pyramid and you slice through it horizontally, what is the resulting figure? If it's a square pyramid, then all these cross-sections will be squares. Basically, it's just a stack of squares. Same thing with a rectangle or some sort of box. They're all going to be the same rectangle. This one obviously would be a pentagon. A cross section of a cylinder will be a circle. The ones that are harder to see is if you slice it up and down. If you slice this up and down, you're going to end up with a triangle. If you slice this or a cylinder up and down, you'll actually end up with a rectangle. So starting with a Coke can, what happens if you slice it horizontally and then again vertically? Slicing it horizontally, you'll end up with a circle. So horizontal if you slice it vertically, this is a little harder to see, but what happens is you actually end up with a rectangle. If you slice this vertically, you can think of it if you actually sliced it and opened up the can, you would have a rectangle on that side and then a rectangle on that side. Well, how about a pyramid? If you slice a pyramid horizontally, it's just a bunch of squares. My picture's not very good, but that's assuming it's a square pyramid. It could be a rectangular pyramid. And then vertical, it's a little harder to see, but if you slice this way, basically what you have is you have a triangle. And again, if you think about slicing it open, you'll have you get the idea. But this is going to be a triangle. Now, why is that important? Well, it's important because of something called Cavalieri's principle. Cavalieri's principle says that if two shapes have the same height and the same cross-section at every level, that means if I slice this horizontally towards the base, I'm going to get a circle. If I slice this horizontally here, I'm going to get a circle. If I slice it in the middle, I'm going to get a circle. If I slice it at the top, I'm going to get a circle. It's going to be the same for both of them. It doesn't matter that they all have to be the same circle. That's what I call the stack of coins principle. If they have the same cross-section at every level, the same as each other, then they have the same volume. So it's actually a fairly simple concept. And basically is what it allows me to take the volume of this skew cylinder here. It says use Cavalieri's principle to find the volume of this cylinder. Well, the volume of a cylinder is r squared h, pi r squared h. It doesn't matter that the cylinder is off to the side because it will have the same volume as a cylinder that's not skew, that has a diameter of 2 meters and a height of 3 because of Cavalieri's principle. So I can find the volume of this regular Coke can cylinder, and it will be the same as the skew cylinder. So pi times r squared, remember r on this one is 1, times the height, that's just 3 pi. That's the answer, 3 pi meters cubed. And of course, if you want a decimal approximation, that's 9.42. And it's Cavalieri's principle that lets me do that. It doesn't really matter what the shape looks like. So for example, if you have a cone, the volume of this cone will be the same as a volume of the cone that has the same diameter and the same height, regardless of where the peak goes to. So the formula for the volume of a cone, anything that comes to a peak, don't forget to divide by 3. And again, don't let me fool you. The diameter is 30, the radius is 15, and then the whole thing gets multiplied by 25. And that's the answer. That's 1875 pi, and that's feet cubed. Again, that is approximately 5890.49 feet cubed. And that is Cavalieri's principle. What allows me to do that is the fact that this shape, this cone, has the same volume as a cone that goes straight up and down. Cavalieri's principle. One more, even if it goes off to the side, as long as it comes to a point, the formula is 1/3 diameter, not diameter of the base, the radius of the base, times pi, all of that raised, all that times the height. Even if the shape goes off to the side, it still has the same volume. So, and of course, is 16/3 pi feet cubed. That's kind of weird looking, so we're just going to say 16.75. Pi and 3 are very close to each other. That's why it's in the neighborhood of 16. And that's cross-section and Cavalieri's principle.